Hello and welcome back to the SIRIUS short course tutorial series. In this video, we'll demonstrate how to leverage the new Structure Sketcher to enhance your results. SIRIUS offers multiple layers for validating structure database search results. These include compound class predictions and substructure annotations, which we covered in a previous video. Today, we'll use an example to illustrate how manually modifying a structure can lead to a better annotation. First, let's use substructure highlighting to pinpoint parts of the structure that appear incorrect or suspicious. Green substructures are supported by fingerprint evidence. Pink substructures contradict fingerprint evidence. Yellow substructures have mixed support, and uncolored substructures are not clearly covered by fingerprint evidence. Knowing which parts seem suspicious, we'll consult information from other views to gain insights into the true structure. For instance, consider the predicted compound classes. This feature is categorized as dibenzothiazepine, which are derivatives of thiazepine featuring two benzene rings. Clicking on the compound class will open the classifier website, providing a visual representation of such structures. Although our best candidate structure is tricyclic, it lacks the central thiazepine ring. Next, let's examine the substructure annotation results. The best candidate structure doesn't seem to explain some of the fragment peaks. You can click the square root intensity button to reveal smaller peaks. The blue peaks are explained by a molecular formula in the fragmentation tree, but not by a substructure of the candidate using combinatorial fragmentation. We didn't obtain any identity hits from the spectral library search, but we did find analog hits that might help explain the fragments. For example, we can compare our spectrum to quetiapine sulfoxide, which is a dibenzothiazepine and exhibits a high cosine similarity to our query spectrum. We can select one of the unexplained peaks to match it in the analog spectrum and observe that it's explained by the loss of the dibenzothiazepine's triple ring. With both validation methods pointing towards this structural motif, we might consider modifying our candidate in this direction. In the Structures view, you can right-click on the candidate and select Modify Structure from the context menu. The sketching area is based on Ketcher, which is an open-source web-based chemical structure editor. This is where you'll draw and modify chemical structures. On the left, you'll find a list of allowed molecular formulas, which includes all molecular formula candidates for which a fingerprint has been predicted. We could begin crafting the dibenzothiazepine triple ring within our candidate structure. In this particular case, it might be even simpler to copy and paste the SMILES string of the analog match and modify that structure. Once you have drawn or modified your structure, click Add to include the new structure in your candidate list. If we try to add this structure directly, we'll encounter an error message indicating that no fingerprint was predicted for this molecular formula, as we still need to add the missing oxygen. Let's try adding it at two different positions in the side chain and add both new structures to the candidate list. We've now added both new structure candidates to the list. Let's see how well they score. We close the sketcher and switch to the de novo results view. Here, we see both new candidates. One ranks worse than the original candidate. In contrast, the other candidate achieves a much better score than the original, and the highlighting suggests that our structural rearrangement was quite effective. We can use the different filters to gain a better overview of how our newly generated candidates rank within the overall list. For instance, we can toggle whether to display database hits or use the database filter to show only our sketched candidates. Finally, in the Substructure Annotations view, we can verify whether our new candidate explains the peaks more effectively. Here, we observe that more peaks are now explainable. For example, this previously unexplained peak is now explained by the dibenzothiazepine loss, and these two peaks are explained by the new sidechain. Thank you for watching. For more tutorials, please subscribe.